Welcome. Welcome. This is the Computer Science and Engineering webinar. We're going to discuss the program. My goal today is to engage with you and get you to ask questions and try to answer all of your questions. My name is Paea Le Pendu. I'm a professor. How do I advance this slide? Just by clicking on it. My name is Paea Le Pendu. You can call me Paea or Professor Le Pendu. I'm pretty flexible about that. My good friends call me Pi, as in 3.14. And if you can't tell, that's because I was a math major, and it's kind of an inside joke amongst my friends. But my PhD is in computer science, and a PhD means I have a doctorate degree. So what's important for me today is to make you feel comfortable talking with me so that I can answer all of your questions and make sure that you have the courage to ask me as many questions as you have on your mind. A little bit about me. I teach introductory computer science programming courses. I teach automata theory, which is a kind of a math/computer science course on the foundations of computing and why they work the way they do. I also teach the artificial intelligence course. I've taught natural language processing. I've taught databases in the past. I teach kind of the whole gambit in computer science. But importantly, I also teach the first year seminar, which all of our majors in computer science with business applications, which I will speak to about today as well. If you're a potential CSBA, we call it computer science with business applications major, and also computer engineering. Finally, I'm the faculty advisor for computer science and CSBA, which means I approve all petitions and I work with our staff advisors to help students through difficult moments and make sure that you're making progress to your degree and all of those good things. And I'm finally the chair of the Computer Science and Engineering Department for the undergraduate curriculum, which means I help oversee all of the programs that computer science is involved with. And there's a lot of them. Again, I'm going to focus on three things today: computer science with business applications, and computer engineering. But other programs, data science, for example, and robotics, also fall under the purview of computer science and engineering. And if you happen to have questions about those, I can field those questions as well. But I'm not going to focus on data science and robotics today. We have other faculty who are going to be talking about that in separate webinars. I'll explain what computer science with business applications is as we go. And I'm hopefully going to get some questions from you about what's the difference between computer science and computer engineering. And I'm happy to go into that. I do want to mention I'm the computer science faculty advisor for computer science with business applications. Professor Alan Knight is the faculty advisor specifically for computer engineering, and Professor Mariam Saloom is the faculty advisor for data science. And all three of us work very closely together. We know each other very well, and we together handle all four of these programs very closely together. Robotics is a kind of a combination of three different departments: computer science, mechanical engineering, and electrical engineering. And that one is advised by the electrical engineering department mainly. So that's a little bit different compared to the other four. Anyway, if you have questions about any of these, I'm happy to answer them. Looking at the bigger picture, right? So computer science and all of its various programs are all under the umbrella of the Bournes College of Engineering. We call it BCOE for short. Those are programs in bioengineering, chemical and environmental engineering, data science, like I mentioned, material science and engineering, mechanical engineering, and our newest edition, I think since maybe, was it last year when we launched it? Don't quote me on that. It was 1 or 2 years ago, robotics. We have a robotics undergraduate degree program and a graduate degree program in robotics now, which is pretty exciting. Today, like I mentioned, I'm going to focus on computer science with business applications, which is very similar, and computer engineering. But again, if you have questions about data science or robotics, I can also answer those. I know very little about bioengineering, for example, or chemical environment. Please go to those webinars if you're interested in those, because I wouldn't barely represent them if you ask me questions about those. So BCUE, the college itself, is top notch, right? Top 50, for example, number 3 in Hispanic serving institutions in the nation. But what I really want to talk about is computer science, because while the college is top 50, which is really great number, maybe if you're in a marathon at school, for example, top 50 may not sound good, but compared to all the colleges and universities in the country, top 50 is an amazing number. But computer science itself, excuse me, I'm getting over a little bit of a cold, so I might wipe my nose a few times. Computer science itself is 28th, according to computer science rankings, csrankings.org. And this is based on research. What does number 28 mean? Let me give you the grand scheme of things. Where is number 28? So that puts us, for example, way far above of Boston College, which you may have heard about, right? I went to University of Oregon for my PhD, and that's 92. And I think University of Oregon is a pretty great school. In fact, top 100 is usually a pretty great school, right? Drexel, University of Arizona, Dartmouth are way below number 28. All schools I'm sure you've probably heard about. Arizona State. I taught at Arizona State for a year before I came to UC Riverside, and they're at about 46 in CS rankings. So this is just to give you a sense of how we compare. But getting closer to that ranking, you'll see schools like Yale, UC Santa Cruz, or UC Santa Barbara, and UCR is above those even. So what is above UCR according to the CS rankings? These are schools that are really amazing in computer science. For example, Carnegie Mellon is almost always ranked number 1 in computer science. Carnegie Mellon University is in Pennsylvania in Pittsburgh, and that is well known for being one of the top computer science schools. Other schools on that, high echelon would be things like Stanford, which you probably have heard of, Columbia, or the University of Washington. So that gives you a sense for number 28 is pretty amazing, and we're very proud of it. If you want to see all of these stats, there's a website called Facts and Rankings on the UCR BCOE website, which you can Google. In terms of enrollment, how big is the college? There's about 4,700 students, of which 3,600 are undergraduate students, college students versus graduate students, for example, different numbers. We have master's students and doctoral or PhD students. Where is computer science in the mix of this? Because this is college-wide. Computer sciences makes up about slightly over, or maybe slightly under. It's just about half of the entire college. So the computing programs are really core in the College of Engineering. Jobs. What kind of jobs could you do if you majored in computer science? The list is so huge that I had to make the font really tiny. And I got this off of a Quora post. I just Googled it. There are so many websites with so much information. I thought this one was pretty nicely organized, and I thought I would share it with you. Some of the examples are the obvious ones, like software development, right? Web development would be a good career choice and a common one. If you're interested in gaming and game development, that's something a computer science graduate could do. One that I think is going to be really, really important and on the rise is cybersecurity. So you can see that on this website too. Right now, the really hot topic, as all of you are probably hearing about quite a lot, is artificial intelligence, or AI, generative AI. There are jobs in that area. One of the ones you may not be on your radar, for example, are DevOps engineering. That's really like back-end engineering, right? Systems design and systems administration type engineering to get kind of the back end of systems going for really large-scale deployments, for example, and product management, especially if you're thinking about the computer science with business application major, where you use a combination in the upper division requirements between business and computer science. It's kind of the combination of the two. you would be really well suited for a job, for example, in product management, which may not be an obvious choice, or IT consulting. So, there's a lot to digest on this slide, but the idea is here that there's a lot of jobs that you would be qualified to do with some kind of computing major. And this goes for computer science with business applications, and computer engineering. A lot of times when you're thinking about college, I was when I was preparing this talk, I was thinking, what was I thinking about when I was applying to college? I remember thinking about medical school, for example, versus engineering, for example. And I remember one of the things I looked at is what kind of jobs can you get and how much do they pay? So I thought I would give you a actual real life scenario. I mentioned I'm the faculty advisor. One of the things I encourage my students to do is come talk to me to help them negotiate their job offers. And literally 3 days ago, the student came to me with this job offer. $130,000 starting salary, which is an amazingly big amount of money. $110,000 stock grant. What that means is the company was going to give them stock options, not stock options, a stock grant, which is $100,000 worth of stock in the company. And just for accepting the job, an extra $80,000 to top it off. That is an amazing amount of money. Plus, because it was in Seattle, you can probably guess the company, it was Amazon, $7,000 to help them move. So I'm going to give you a little bit of a homework assignment so that in case what I'm saying is not super exciting to you, I'm going to give you a little task to do. I'm sure all of you are taking some kind of math. This is not very difficult math. But let's assume the following. Given this job offer, let's say you only spend about 50% of your salary. So you have $130,000 salary and you only live off of $65,000 of that every year. Okay? Maybe it goes up a little bit as inflation goes up. Let's say we assume, for example, you pay about 30% in taxes. So you have to do the math on that. And let's say for all the money that you don't spend, you're going to put it in a savings account or an investment account, and you're going to let it grow at 8% annually. So I want you to do some math here. I want you to calculate, given this offer and all of these assumptions, how much money would you have after 2 years, 4 years, 20 years? And give yourself a minute to figure that out. Well, I'm going to keep talking. I've already done this because I was really curious because when I started, I had a degree in mathematics, but then I kind of went to school at night to learn computer science while I was working. My salary was nothing near this, so this is a really impressive starting salary. This is not uncommon, I should say. Like I said, students come to me and share these job offers with me, and I help them negotiate to see if I can increase their stock grants or, make sure that they ask for a travel allowance. A lot of times students forget to ask for the travel allowance. So that's why I encourage them to come talk to you to make sure that they're getting the best possible offers. So hopefully while I'm talking, you did some of that work. I would pretend that, so did I, but really I did it in advance. This is what that scenario would look like. So I put it in a spreadsheet. You probably heard of Google Spreadsheet or Excel. I just use Excel to do this. And I put all the assumptions as columns, put little formulas in there. And this is what it looks like. Actually, this student is not even 23 years old. This real scenario, this student is actually 20 years old, graduating with his master's degree because he went through what we call the BS plus MS or 4+1 program at UCR. Really amazing, right? Like, here's all the assumptions in the screen here. By 35 years old, this person will be a millionaire if he does these things. That's amazing. I was not a millionaire by 35. There's no way. But this is the kind of thing that happened when you get a degree in computer science. The financial outlook is pretty amazing. And you don't have to take my word for it. If you can just look at it, Google it, the Bureau of Labor Statistics, which is kind of a website that the government manages that collects and makes projections about different careers nationwide. Computer and information technology ranks at the very top of that. In fact, the median annual wage for this group is about $104,000. But as you can see, UCR graduates are very sought after, and they're getting offers above the median. Anyway, I'm excited to share with this. When I heard this, I was super proud of this student. I won't tell you their name just for their privacy. I'm going to switch gears a little bit to talk a little bit more about what makes UCR amazing, in my opinion. I went to a small liberal arts school, Whitman College in Eastern Washington State, and to compare that with UCR is like apples and oranges. And this is the reason why. It's about research. So the question that I want to pose is, what is research like at the most diverse, research-intensive, world-class public university system on the planet? And I'm talking about the UC system-wide, which includes UC Riverside, Berkeley, UCLA, and so on. Hopefully this works. I spent a lot of time on this. I'm still using this example because I'm assuming, for those of you who are attending today, some of you have seen the movie Frozen. Am I right? Like, this is not from the movie Frozen. This is just a YouTube video that I found online. The reason I'm showing this is we have professors who do research in graphics. Tamar Shinar, she's one of our amazing research faculty who does graphics research. And one of the movies that her work is featured in is called WALL-E. If you haven't seen it, it's a great sci-fi movie about robots and things like that. But what I'm showing you this one about is Frozen, is one of our professors, Craig Schroeder, Professor Craig Schroeder, I should say. He was instrumental in designing state-of-the-art algorithms using advanced mathematics, for example, linear algebra. Some of you are probably studying linear algebra right now, and differential equations, which you'll probably learn about when you go to college, to basically mimic snowfall. This revolutionized the animation of snow in movies, specifically in Frozen. And Craig was one of the guys on the team who engineered the snowfall in the movie Frozen for Disney. And we think that's pretty amazing. What does a mosquito, a laser pointer, and an earworm moth and a seal have in common? Well, just for fun, I took this query and I put it into ChatGPT. Well, not really ChatGPT, but OpenAI has an image generative AI, and I put it in there, and it came up with a bunch of images. I thought this one looked cool. It had nothing to do with the research, to be honest. But what I'm talking about here is we have a professor, Professor Amon Keo, who is very famous, for example, in data mining and machine learning. And he came up with this one algorithm to look for what are called motifs, which are patterns, repeating patterns in time series data. What is time series data? Time series data are like stock markets. You know how they have graphs in the stock market? Or what's another example of a time series? An echocardiogram. So if you're monitoring someone's heart rate, you see the heartbeat go beep, 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 beep. Those are all time series data. And especially, for example, in a heartbeat, there are regular patterns that doctors, for example, look for. Well, with mosquitoes, what Professor Keogh did, and he actually said that he got the idea from watching Mission Impossible, where I guess someone was shining a laser on a piece of glass from one building to another building and measuring the vibrations in the glass using the laser to basically hear what was going on in the room, just using a laser. And he thought, in his amazing little mind of his, like, can I do this to measure the flaps of a mosquito's wings? Like, why would he say that? Because he works very closely with our entomology department, that means the science of insects, which has a worldwide reputation in agriculture. You know, I don't know if you know this, but UC Riverside invented the cutie orange, right? For example, we're very famous in orange, citrus, and insects. So he was really curious about finding a way to use a device using lasers, because lasers are cheap and low powered, to not just look at mosquitoes, but the earworm moth is a pestilent bug that infects crops all over the world, including corn and citrus, for example. And so basically, long story short, he invented a technology that is in a very small little box. You can put it into a field, and as the insects go through that box, you can tell what kind of insect it is using machine learning. So that's the answer to the question. What do these all have in common? Machine learning using advanced algorithms. What does a seal have to do with it? He had a device that he was measuring that had like a collar on the seal, and they were kind of observing the seal's behavior over the course of months, and they were noticing these interesting patterns for the seal. And there was this weird pattern that came out as a motif using his motif algorithm. And they're trying to figure out, like, what is this pattern that keeps happening? It turned out to be feeding, right? If you imagine a seal is feeding, catches a fish, there's all this flurry of activity as he's chasing the fish down. But then there's a lull and then a little blip in the data. And this motif algorithm was picking it up, and they're trying to figure out what it was. Well, usually when a fish is chasing a seal, it catches it usually by the tail. But you can't really eat the fish from its tail, right? So what happens is the seal kind of takes a break because he has the fish in the mouth. He comes up to the surface, and then you've probably seen pictures of this. The seal flips the fish in the air, so the fish turns around and catches it by the head, which is much easier to swallow by. And this motif algorithm was picking up these specific patterns for the seal. So, very cool stuff that Professor Amon Keel does. You probably recognize this picture. This is DNA analysis. We have a professor, Stefano Lenardi, who does amazing work doing what's called DNA reconstruction by, very fancy algorithms. Because I don't know if you know this, but when you're trying to kind of reconstruct a DNA sequence, what happens is they take the DNA and they break it down into many little chunks, and then they can look at each of the chunks for the specific genes, but then they have to reconstruct those in the right order to kind of understand the entire gene sequence. This is a very difficult thing to do because it's kind of imagine shattering a piece of glass into a million pieces and then having to reconstruct it and put it back together. That's kind of what DNA reconstruction is about. And Stefano Lenardi has amazing algorithms that are not unlike the algorithms used for Google searches, for example. It may not seem connected, but these search algorithms allow him to find and reconstruct and piece back together these amazing sequences of DNA. Why is this important? He has helped to reconstruct many different important DNA sequences, for example, for the cowpea. You might have heard of black-eyed peas, it's the kind of cousin of the cowpea. And that's important because they grow in very unique conditions, similar to, the Riverside area, but also sub-Saharan Africa, where there's huge droughts all the time. And these peas can survive in highly drought-tolerant environments. And that's really important because, when the apocalypse comes, these kinds of crops are going to save all of us. And so understanding them through their DNA is really important. And we have professors that do that too. How much time do I have left? I'm doing pretty good, 24 minutes in. Since we have a few more minutes, I'll tell you a little bit about what I do. My area of research is in biomedical informatics, not specifically bioinformatics, which would, be involved with gene sequencing. I don't do gene resequencing. I focus on patients, clinical informatics. So I don't know if you know about this, but our United States, we have a three-payer system. Basically, there's the payers, which are the insurance companies, the providers, which are your doctors, and the patients who ultimately foot the bill and are receiving care are not usually at the center of this universe. There's a tug of war between the insurance companies and doctors that really kind of take away what really should be the most important thing is great patient care. And I use sophisticated algorithms in text mining or natural language processing and knowledge representation and reasoning, which is like AI, on medical records, including doctors' notes and nurses' reports, to really understand what's going on with patients and make sure that we can ask really deep and sophisticated questions and advance the state of the art in medicine. That's my research. But to just kind of make it accessible to everyone, here's a simple example. One of the first problems we solved using, the algorithms that we created for data mining, medical records on a massive scale. And I'm talking processing about 50 million records at a time. That's a pretty large amount of medical records. If all you did is search for certain keywords like Vioxx or Celebrex or their active ingredients, which are called rofecoxib and celecoxib, in the medical record, you would see a very simple pattern. As like you see here, here's another example of time series data. So Celebrex is the orange one. You can see that this drug, and what we're looking at is just drug mentions. How many times is this word mentioned in the medical record? And in 2004, clearly something happened, right? And what happened at that time is the Vioxx drug and the Celebrex drugs were getting mentioned less and less in the record. And eventually around 2006, the Celebrex drug got mentioned more often again and kind of, went back on trend. But the Vioxx mentions never recovered. And the reason for this, looking back in history, is very clear, right? In 2004, Vioxx was recalled from the market because it was unsafe. It was killing a lot of patients, and when I say a lot, I mean a lot, like tens of thousands. It was horrible. They were getting heart attacks and strokes after taking this drug. But as you can tell, it was offered as early as 1999. So over the course of these 5 years, people were taking the drug and dying, essentially. That's not a good thing. So the question we asked is, can we detect this earlier and prevent, 4 years or 5 years of this adverse drug effects? Adverse drug effects means bad things that happen after you're taking the drug. And it turns out, and we did the analysis using the Stanford medical records over the course of 17 years, that you cannot do it by using the structured medical data alone. By structured medical data, I mean the codes that when you go to the doctor, you get codes assigned for your medications, and you can get codes assigned. This is structured data. People are typing in a specific keyword or code for those things that are prescribed or mentioned in the record. Just by looking at that, you would not be able to see that this drug is hurting people. But if you look at the medical notes, what the doctors write, their notes, you can see the signal. And that was a huge change in the way we addressed medical of what's called pharmacovigilance, which is drug safety. And the FDA wrote a long story about this work, like this is going to change the state of the art in drug safety. And simple techniques work really well when you have huge amounts of data. All of this is just to say, if you come to UCR, being one of our majors means you will be exposed to cutting edge research. And that's a really good reason to join UCR. That's what sets UCR different, for example, from where I went to as an undergrad, which was Whitman College, which doesn't have this level of research that you would be exposed to. One last thing to mention, I'm the principal investigator, which means I helped UCR help get, it wasn't just me, I should not take all the credit. It was a team of people that I worked with. $2 million in funding from the National Science Foundation to help you pay for college. So what this means is every year for the next 6 years, we're going to be accepting 20 new students into the Scholar Excel program, which will fund you for about $26,000 to $80,000 total over the course of your 4 years. And if you stay one more year to get your master's degree in our BS plus MS program, sometimes schools call them 4+1 programs, which that means is you spend 4 years as an undergraduate plus 1 year, extra year, you get a master's degree as well. We'll pay for that too. We offer immersive experience and research and industry. If you want to get an internship, We'll pair you one-on-one with faculty mentors to make sure you get the very best attention and access to research and internships and all that. And basically, all of you are probably eligible because most of our students are low income at UCR, and that's something we pride ourselves in. A lot of our students are first generation low income students, and all of you will have a 3.8 GPA or above if you get accepted to UCR. So pretty much almost all or most of you would be eligible for this scholarship. So we're going to actually email you if you apply and encourage you to apply for these scholarships so that we can fund your next 4 years. Okay, I said a lot. How much time do we have? Great, lots of time, 15 minutes at least for discussion. What I'm going to do is what I'm going to tell all my students in college. When you come to college, I look for students who are really good at taking notes, being really thoughtful, and asking great questions. Okay, so I put on the screen some questions that I think you might have of me, but I want you to spend the next, let's say 30 seconds. Take out a little piece of notepad or a piece of paper or a sticky note. If you have a cell phone, you can jot it down on your cell phone. Think of 1 or 2 questions that you really wanted to know about college in general or UCR specifically. And then take your time. When you ask your question, I mean, it's okay if you want to do it anonymously. If not, I would love to know your name so I can talk to you specifically. I really like engaging with students one-on-one. If you're not too shy to do that, I'd be happy to talk to you. Say, my name is so-and-so. I have this question. So why don't you take 30 seconds to do that? And then we'll go to the Q&A phase. I see we have about 9 attendees, which is really great. I can see your names in the participant list if you want to put your questions in the chat. I think the chat is turned on. You can use the chat. Or if you want, you can use the official Q&A feature and we can queue up your questions. I'm pretty flexible. Whichever way you want to engage is great. I actually see a question in the chat. If I want to work at NVIDIA after I graduate, which major would be the best? Thank you, Jed. That's a great question. NVIDIA, if you don't know about this company, is famous right now because they're kind of leading the edge in GPU, graphics processing, unit architectures, and chips, basically, that are currently powering ChatGPT, for example. Right? All of these generative AI models are using these advanced chips that most famously NVIDIA is behind. And their stock has been going through the roof. So it's a really popular company right now. So what's the major? Most likely, they probably have a lot of jobs. I don't work at NVIDIA, so I don't know specifically. But they have jobs that probably, are across the whole gambit. So I'm sure they have positions in data science. I'm sure they have positions in computer science. I'm sure they have product managers and they need people who do computer science with business applications. But the most obvious fit would be computer engineering. And the reason why is computer engineering and computer science are similar. They overlap almost 50%, right? You have to know how computers work. But really with computer engineering, you go into kind of the hardware level itself. So it's a combination of the computer science plus the engineering, the electrical engineering behind how the chips work, the architectures and all that. That's kind of the difference. And I bet that's kind of where most of our graduates in computer engineering would go into fields like NVIDIA because it's really chip-based. Great question. Hi, Richie. Thanks for your question. I'm not sure I got the whole question, but I can see part of it. It says computer science with business application requirements. So if you want to finish that sentence, or I'm going to assume, for example, you mean what are the requirements for computer science with business applications? They're very similar to computer science itself. The main difference is computer science requires you to take a few more technical electives in computer science itself, which are very broad. They could include AI and data science types courses. But in computer science with business applications, they'll take those technical electives. It's about 8 courses you take during your junior and senior year. They split it half and half. So instead of 8 courses in computer science, you'll do 4 computer science courses and 4 business courses. So that's kind of the main difference between the 2 degrees. But in my opinion, if you get a computer science with business applications degree, you have a computer science degree. Okay. And the reason I say that is we just are going through the ABET accreditation, which is the accreditation for engineering colleges, and computer science with business applications is being accredited as a computer science program. You're welcome. Thanks for asking. What other questions do we have? I'm sure you have a lot. Don't be shy. If you want to post your question anonymously, you can use the Q&A to do that.
Professor Le Pendu, we have a follow-up question, and it's related to computer engineering and computer science. We have 2 people asking similar questions. I just want to throw this question out for now. What is the difference between computer science and computer engineering, especially when it comes to UCR research opportunities, and when it comes to the nature of jobs for a graduate would be more likely to be hired for? And then Mohammed is following up and asking, what would you be learning in computer engineering and what kind of fields can you go to?
Great questions. And that's a really common question because it's really easy to confuse the 2, right? Or lump them together. Computer science and computer engineering sound very similar. I'm going to talk about computer engineering specifically in terms of embedded systems as an example. Embedded systems are basically, how do you say this? Programs that run specifically on chips, not necessarily in software. So it's really kind of getting to the hardware level, right? So if any of you have used Raspberry Pis or done anything in robotics, in college, you're more on the engineering side, computer engineering side, because it tends to be more focused on the hardware. And by hardware, I mean the chips, the memory, the computer architecture, right? How does the computer itself work? And if the apocalypse came, you would be the one to rebuild computers. That would be our computer engineers. Whereas computer science is more general and it can be hardware level, but mostly computer science tends to be about software. Okay. So programming skills, analytical skills, strong algorithm and mathematical skills, and maybe web development fall under that. Data science is also connected to computer science, right? Data science is typically half computer science and half statistics, more or less, with some deep application areas. But computer engineering, what makes it different is it's really kind of a melange or mix between computer science and electrical engineering, which is more concerned about the construction of the computer itself. Did I answer that question? In terms of the major and like the requirements, the first 2 years of these 2 almost are identical. It's really when you take your technical electives that they start to feel and look different. So the first 2 years of the computer engineering, computer science, and computer science with business applications are almost identical. You take all the same classes. That's why they're very much overlap.
And now I think we have a question that's a little bit of myth busting. My dad said the AI will replace computer programmers in the near future. Do you think it will be hard for CS majors to find jobs in the future?
That's a great question. How do I answer that one? Honestly, right, myth busting. We have students, for example, in our introductory series that could easily use AI to help them with their homeworks and do their assignments. And maybe that's allowed, maybe it isn't. It depends on the professor. And sometimes they want you to try using AI, sometimes they want you to do it on your own. But really, yes, ChatGPT, for example, can write code and it does it really well. It can do a lot of those introductory assignments almost as good as, if not better than, our students can, right? But the question you asked is not the same as that. Can it write programs? Sure. Can it do software development? No. Software development is not small pieces of code. It's a much more complicated process that involves design work, architecture work. Um, you have to talk to people to understand their requirements in order to understand what to build and make sure it works correctly. The user interface, UI, UX, is a really important part of software development to make sure that the users can use whatever software you use. AI can't do these things, not yet. Will it in the future? That remains to be seen. That is a much more complicated process. As a simple example, when I worked at IBM for a while, I worked on the database kernel, which means the kind of the core database engine for what's called their DB2 database system. DB2 is for massive companies like Goldman Sachs, Walmart uses it, Nike used DB2, for example. So it's a really big database system. We had 650 engineers working on the code at the same time, right? This is not a small piece of code. There were, I don't remember how many millions of lines of code there were, but it was humongous and it's extremely complicated. It took me months to even understand the project I was working on. AI is not that sophisticated these days. Maybe someday it will get closer to that, but it's a long way out. You have some job security for the next decade at least. I am sure of it. Great question. I mean, the obvious
We,
answer also is somebody has to build the AI, right? That's what we would train you to do. You have to be the engineer, the one that creates these technologies, and the AI doesn't build itself. Sorry, go ahead, Christina.
as a professor who does research, what do you look for when a student approaches you with a research participation request?
That's a great question. We have a lot of resources to help with that. So we have a Student Success Center. We actually have a presentation, I believe, if you want to kind of look at the list of presentations that Christina can share with you to talk about the student support services that we have. They do training on undergraduate research and, helping to place you with different faculty who are looking for students in research. I have 3 PhD students of my own, so I have a research lab that I work with students on. In the past, I had a lot of undergraduates. I think I had about 10 undergraduates at a time. But now that I have PhD students, it's a little hard to have that many undergrads, but I usually have at least 2 or 3 undergrads working with me and my PhD students at any given time. Um, Professor Saloom has been really great. She's the faculty advisor for data science, if you don't remember, at getting grant funding to provide what we call the DS pathway grants and similar opportunities where we have had in the past 3 years 45 different students participate in summer research. It's a lot. And we have right now an REU, which is a research experience for undergrad, funded by the NSF. I'm one of the co-PIs on. This one is the principal investigator of that one is Professor Jia Chen. She's in electrical engineering. We work very closely together. And we take 10 students in that program every year to do research and cutting edge data science and computer science type applications. The NSF program itself, the National Science Foundation, has REU programs across the country. So when I have undergraduates come and ask me, that's one of the first things I point them to. It's like, you can do all the great things you want to do at UCR, but it's really great to go outside of your comfort zone, explore the boundaries, and apply to these hundreds of different REU sites across the country, and we would help you do that.
There's a question. Oh, are courses taught by TAs like in most universities, or are they taught by faculty?
Oh, good question. Some large universities have teach TAs or teaching assistants, which are graduate students teach courses. That doesn't happen, at least not in computer science or data science or computer engineering. None of our programs in engineering are like that. All the courses are taught by faculty, which is really great. You have direct access to our faculty? Great question.
Chloe she's interested in computer science with business applications and is wondering, how does UCR's computer engineering program prepare students to apply concepts like machine learning or data analytics in business contexts? And are there capstone projects or internships specifically geared towards solving business-related problems?
Wow, that's a great question. I'm not sure I'm going to do it justice. Wow, Chloe, you stumped me there. Uh, the computer science with business applications really is a partnership between computer science and business. And mostly it's on courses. So you will be exposed to courses on both sides and you get to design what that looks like for you. At the same time, while it's not required, um, we do offer what are called capstone or senior design courses, and CSBA majors are eligible to take that as an option or an elective. Our computer science and computer engineering, because they're more on the engineering side, are required, but in computer science with business applications, you can choose. So I imagine you probably, based on your question, want to pick one of the many different flavors of capstone courses we have in any of the areas that you want, right? So, for example, we have a capstone in AI if you wanted to do that. We also have, which I think makes UCR kind of unique, an entrepreneurship course in computer science that you could take that's taught by one of our professors who actually runs a company. So I would imagine that would be a fun course to take as a CSBA major. Great question. I see in the chat, Richie asked another question. Do we have scholarship opportunities in the CS departments? Yes, we have a lot of them. We have a lot of endowed scholarships, which means that every year they provide funding for a handful of students. And like I mentioned, we also have the STEM scholarship that is a huge amount of money that we're going to be giving out for the next 6 years. So yes, there's several scholarships, and we will reach out to you to make sure you apply for them.
Professor, there's a follow-up question on the research question. So the attendee is saying, my question was more about what traits would you make you choose a specific student over another? I'm assuming the professor would need to approve the student, or do we just get placed with the professors?
Was that a research question or about, I didn't quite follow the context.
Yeah, it's a follow-up question on the research question.
So how would you choose one research student after another?
Yeah, like what traits does a professor see in a specific student to choose the student for the particular research?
So the truth is most of our students are top-notch, right? So I wouldn't choose based on grades. I would choose based on passion and enthusiasm. So for me, what makes a great research assistant, which would be a student in my research lab, is one who really cares about what we're doing. Because what that means is they're going to put in the time and energy, and no matter what their grades are, they're going to do well because everyone who comes to UCR in computer science is already qualified and talented and ready to go. So it's mostly about finding the right fit, and that's really about your passion and interest and how much time and energy you're willing to pour into the research.
Professor, we have a question. Due to the size of the program, is registration for Comp Sci with business applications classes competitive?
Yes. All 4 of the majors are very competitive, especially when you compare them to the rest of UCR. So if you want to compare, for example, engineering against biology, for example, our entry requirements tend to be a bit higher. And I don't want to say that CS computer science with business application is a lesser major. I don't believe that at all. But the entry requirements are a little bit lower for that, only because we usually have fewer applicants in that area. So if you're interested in computer science with business applications, your chances might be slightly better if you apply for that program. only because the GPA requirements are very slightly lower.
And we have a question about the student clubs and organizations in the CS department.
Great question. We have really highly engaged students, which is great. In fact, we say this during our orientations for our first year students who come in, that it's not really the grades that you get that determine your future success after you graduate. It's really the activities that you participate in that are the determining factor in future success. Those are usually the student clubs and organizations. We have them across the board. We have WINC, Women in Computing, for example. We have SWE, which is for women engineers. We have IEEE, Club for Electrical Engineering, for computer engineering majors. We have the ACM Club for computer science majors. These clubs usually work together to put on what we call the hackathons. So there are about 4 hackathons every year. And I really push students really hard in the first year seminar to join these hackathons because they're kind of the gateway into the student orgs and getting to know each other. And it's just kind of a fun way to get to know your colleagues. So yeah, the student orgs are one of the most favorite things for me at UCR because that's how the students engage with each other and really push each other and help each other through college. Thank you for all the questions. That's been really great. I think I have 2 more slides. If you have other questions about admissions and application and financial aid, general questions, here's the QR code and the website for that. And there is a chatbot you can use, but you can also connect to an admissions officer to ask specific questions about your application and all that. And with that, I'll just say thank you so much for coming and for all the great questions. I'm really glad you took those few seconds to jot down your questions and ask really great, thoughtful questions. You're going to be great college students. Thank you.
Professor, there's another question in Q&A.
Go ahead.
The attendee is asking, what is it like to live in Riverside?
What is it like to live in Riverside? Oh, it's so great. It's a mix. It's in the middle of a residential area, right? It's not in the middle of a big city. So that's kind of nice, right? The college itself, you can walk around and get everywhere you need to go. There's food. The dorms are, I hear, amazing because they're kind of brand new. And what's really nice about Riverside is, while it might not be LA, which is really exciting, it's not far from LA. You can go for the weekend to LA, no problem. It's like 1 or 2 hours away by car. San Diego is about 90 minutes away. Palm Springs, which I like to go to hang out and have great food, good restaurants, is about 50 minutes away. There's so much around UC Riverside that I think it's a great place to live. And it's not as expensive as San Diego or LA. And as you can see in the picture, it's pretty beautiful. Great weather.
Yeah. And there's another question. Do any of the CS majors go surfing at the beach on the weekends? Is there a gym and a pool on campus?
Oh yeah, there's definitely a gym and a pool on campus. It's open all the time, and it's open to all students. And it's really nice.
Okay, well, that concludes our session. And if you have any follow-up questions, please connect with admissions. Thank you very much for coming on a Saturday morning to hear us talk about the great things happening at UCR in the computer science department. Thank you very much.
Thank you, Christina. One last thing, before you go, you might want to write my name down or take a screenshot. Paea Le Pendu is not easy to spell, but I guarantee you there are not any other Paea Le Pendus in the world. If you Google me, you'll find me and you can reach out to me anytime you want.